when solving differential equations, it's important first to recognise the form in which they take. This is because the form dictates what template or what method you're going to use for solving. So if we've got a differential equation of the form dy dx plus ay equals f of x, and we know a is some constant, we can develop a process, or I like to call them template, that we can throw over this type of differential equation and use this template as a method for solving. So let's just go through the different steps. So first of all, we've identified that it's of this form, and my first step is to find the solution if it was a homogeneous equation. Homogeneous equation is where f of x is equal to 0. So we would solve dy dx plus ay equals 0. Now that's a differential equation that is separable, because we can take the ay over here becomes minus ay, bring the y down, dx over the other side, and solve it. We've done this in previous work, so I'm not going to go through that right now. So what we've first of all got to do is disregard this, make this equal to 0, and solve the homogeneous equation. Your next step is to have a guess at y particular. Now y particular, we look at what f of x looks like and what structure f of x, depending on what structure f of x looks like, as to what our guess for our yp or y particular solution will be. And there is a table in your notes, and I've reproduced it here, so that if f of x, the right-hand side of our equation, looks like any one of those, then our guess, or y particular, will take on that form. Now C and D are constants, and E. C, D and E are all constants, and our next step after this will be to try and find C and D and E, if it exists, as in this one here in x squared. Alright, so we've identified what the right hand side f of x looks like, and then we'll make that particular substitution for y of p. So we then need to differentiate and find y dash of p, the particular solution, so whichever one this is. We then substitute yp and y dash of p back in the original equation. Now the original equation is dy dx plus ay equals f of x, so we substitute back in there, and then that allows us to find values for c, maybe cd and e, in our y particular. So we find y dash of p, we substitute yp and y dash of p back in the original equation and find values of c, d and e, and then finally we state the general solution. The general solution is y equals the y homogeneous plus the y particular. The y particular with the values c, d and e that you've found. Okay, so what we'll do in future little mini lectures here is to go through and do a particular example of this.